This video is on medical ratios. Let's look at this problem. Amoxicillin is an antibiotic obtainable in a liquid suspension form, part medication, part water, and is frequently used to treat infections in infants. One formulation of the drug contains 125 milligrams of amoxicillin per 5 milliliters of liquid. A pediatrician orders 150 milligrams per day for a 4-month-old child with an ear infection. How much of the amoxicillin suspension would the parent need to administer to the infant in order to achieve the recommended daily dose? So this problem is a good example of one that looks complicated, but the math isn't too terrible. This is a simple ratio, just like we've been doing. We're told that one formulation of the drug contains 125 milligrams per 5 milliliters. What we want to know is how much of the amoxicillin suspension, so how many milliliters, would the parent need to administer in order to get the recommended dose of 150 milligrams. I'm going to set this up as a proportion. 125 milligrams per 5 milliliters is the solution that I know. And we want 150 milligrams, and we want to figure out how many milliliters that is. This is a proportion. We can solve this by cross-multiplying. 125 times x equals 150 times 5 equals 750. Divide both sides by 125, and we end up with our answer of 6. So the parent should administer 6 milliliters of amoxicillin. This should make sense with what we know about the problem. I know that there's 125 milligrams in 5 milliliters. So 150 milligrams is just a little bit more. So the number of milliliters should also be a little bit more. Let's do another problem. We're given that, we want to give 1,500 milliliters of a saline solution, IV, with a drop factor of 10 drops per milliliter. Highlight some of this. At a rate of 50 drops per minute to an adult patient. And we want to find out how long in hours that IV should be administered. So this problem looks a little crazy, but let's think about units. What we're starting with is milliliters, and what we want to eventually end up with is we want to end up with hours. So I'm going to look at my unit. This is a unit conversion problem, really. So we're starting with milliliters, and then I see that there's 10 drops per milliliter, so I can go from milliliters to drops. And then this thing tells me that there's 50 drops per minute, so that means I can go from drops to minute. And then minutes, I can convert to hours. So this is my plan. Start with milliliters, 1,500 milliliters, and I can say that's divided by 1. And now I want milliliters to cancel out and drops to remain. So I know that there's 10 drops per 1 milliliter, so 10 drops per 1 milliliter. Next, I want drops to simplify out and minutes to remain. That's a reciprocal of what we're given. So we're given 50 drops per 1 minute. But the rate is the same thing as saying this is 1 minute for 50 drops. So that's the conversion we're going to put in because we want drops and drops to simplify out. From here, we want to change from minutes to hours, so minutes is going to go in the denominator, hours in the numerator. I know that there's 60 minutes in 1 hour, so 1 hour divided by 60 minutes. And here, minutes and minutes are going to simplify out. So what we're left with is we're left with 1,500 times 10 divided by 50, also divided by 60. And this ends up just being in hours. So multiplying this all out, 1,500 times 10 divided by 50 times 60, 5. The IV should be administered for 5 hours.